Okay. Beside of inverting amplifier, the op-amp can be applied as several others circuit or others application. Okay, one of them is we have the voltage follower, we have a non-inverting amplifier, we have a summing amplifier, and we have a subtractor. Okay, subtractor. Okay, so I like to note here this type of amplifier application is a linear application. This is a linear application. So this is the application that relate to this is the application that which is a analog application. So we have done this inverting amplifier. So next we go to the voltage follower and unity follower. So voltage follower slash unity follower is a very simple application. So what it does is it transfer, so unity follower transfer the same value, the same voltage value from input to output. Okay, so basically it's something like connecting a wire from one point to one point, because it transfer the one voltage the same voltage one point to another point. But there is difference between the wiring and the voltage follower or unity follower. Okay. So before that, we see in terms of the circuit analysis why the VI equal to V out. So V out or equal to VI, because here V plus is equal to V in. And then since V plus is equal to V minus, so V minus is equal to V in, and then V out is equal to V in. So that's why we can get a voltage follower. So what's the point? What's the point? The point is, due to the infinite input impedance of op-amp, no current can be drawn from the circuit before the V in. Okay, so this part is effectively isolated. So very useful for interfacing to high impedance sensors such as microelectrode and microphone. Okay, for example, you have a 2-block circuit, you have a 2 sub-circuit, circuit 1 and circuit 2. So you want to transfer the output of the output of the C1, you need to be transferred as to become the input of C2. But if you do the direct coupling, so the performance of the value of the output C1 will change, will degrade, for example, will change. So to solve the problem, you can use the op-amp. So op-amp can transfer the voltage, at the same time it isolate the two block. Okay. So this is the voltage follower or unity follower. Okay. Another name for this type of application is the buffer. So this is what we call it as a buffer block. Okay. Next we go to the next application, non-inverting amplifier. Okay. In the first example, I have shown the inverting amplifier. So non-inverting amplifier is the circuit that give gain but give the positive gain. So this is a positive gain. So what is the difference between inverting and non-inverting? In non-inverting amplifier, the input is connected to the V plus. Okay, but the feedback still is a negative feedback, so the negative is connected to the ground. Okay, so how we need to analyze it. So how to get the equation for V out? We start with the KCL at this node, at the node here. So KCL, the current is level here, I1, I2, and then we have here, this is current I negative. So the entering is I2 only. I2 is entering, I1 is exiting, and I minus is exiting also. So equal to 0. So I minus is 0 because the input current of op-amp is 0 due to the high infinite impedance, input impedance. Okay, for I2, I2 is can be expressed as a V minus over R1. So I2, sorry, not I2, this is I1. So I2 is V out minus the V minus over R2. So this is V out minus V minus over R2. Okay, for I1, mistake. Okay, for I1, this is the voltage is V minus over R1. Okay, so this is equal to 0. So due to the, and then we know that V plus is equal to V minus, and then V plus is equal to V in. So therefore, the equation of KCL, the equation can become like this: V in over R2. This is V in R1 equal to 0. Okay, you solve this equation, you will get the V in, this is R1 plus R2, R1, R2 equal to 0. So V out is equal to R1 plus R2, R1. Okay. So this is your answer. Or sometimes it written as V out equal to 1 plus R2, R1, V in. So this is the derivation of output equation of the inverting amplifier, non-inverting amplifier.